Okay, so okay, so let's look at.
Sorry, I didn't mean to leave.
That's all right. So let's look at the inequalities here. Okay, so next thing we're going to be talking about inequalities. But what exactly is an inequality? And I mean, how is this different from an equation, right? Because we have x equals 3, but then inequalities, there's 4 different types of inequalities. So what is, before anything, what does an inequality mean? Does anybody have an idea? So when we have an equation, we say something, see, we say that x is equal to 3. When we look at that, x is equal to 3, is there any other possibility that it could be? So if I tell you x is equal to 3, can x also equal 2? Or can x also equal 1? No, right? The equation, the equal sign tells us that x is only equal to one thing. X can only be equal to 3. So this is where inequalities come in. Okay. And inequalities kind of starts getting the basis of like coding and computers and stuff like that, because a computer can process a lot of things, right? Not just one thing. Okay. So let's just say the variable represents like something that I could do, on a computer. So there's an infinite amount of possibilities that I could do in a computer, right? So that's sort of like the basis of what an inequality is, right? So reading the first one, x is greater than 3. How do we interpret that? What kind of solutions can that have? Because there's multiple solutions as long as they're greater than 3. So what kind of solutions could we have if we have x greater than 3? Okay. Let's see. Okay, so let's say we have a number line. Okay. If we're saying that x is greater than 3, would it work if we said if x was equal to 4? That would make sense, right? 4 is greater than 3. What about 5? If x was equal to 5, then 5 is greater than 3 as well. And 6, 7, and we can just keep on going, right? So on a number line, we could say, okay, as x is going to be everything as long as it's greater than 3. Okay. So then let's look at the opposite. What about x is less than 3? Okay. So what kind of solutions can X be? And again, as long as it's less than 3, so what kind of solutions could we have? 2, Sammy, you said 2, 1, 0, exactly. So everything that is less than, so 2, 1, 0, -1, exactly. So on a number line, we could say everything that is less than 3. Okay. So now let's look at these right here. Now, what makes those different? We say X is greater than or equal to 3. So what's the big difference between that and the inequalities on the top? So Sammy said it could equal to 3, okay? So in the first ones, we were saying X is greater than 3, but can 3 be a solution? It cannot. And if you notice, I drew an open circle. What that open circle tells us is that we're not going to include the 3, okay? So we're going to graph them the exact same way, but instead of an open circle this time, we're going to put a closed circle. Same thing on this one. We're going to put a closed circle and move it towards the left. So what that closed circle tells us is that we can have 3 as a solution as well as everything below it. So 2, 1, 0, -1, -2. And if it's greater than, we can say it can be 3 as well as 4, 5, 6, 7, 8. Okay. So this is the main difference with the inequalities. So okay, so now we have 6x plus 2 minus 4x is greater than or equal to 8. So when we're solving this, there's really no difference with solving this and solving a regular equation, okay? There's only one key difference, but when we get there, I'll show you what that is, okay? But if we were to solve this, we can just do the same thing. We're gonna draw, well, we're gonna draw a line straight through that. And let's look at each side separately, okay? Is there anything that we can do on the right side? No, right? The 8 is already by itself, so there's nothing we can do. What about the left side though? What is the first thing that we should do on the left side? We need to simplify it as much as we can. So what is the first thing that we can do there? The parentheses, but also basically saying we can distribute, okay? So we're gonna distribute. That should be 6 times x And there's a 1 there, so we can just say 6 times 1, which is 6x, and 6 times 2, which is 12. Okay, what's next? What can we do after that? How can we simplify the left side? Any ideas? So 6x minus 4x. Or we can combine those terms and we can say 6x minus 4x would give us 2x. So now if we subtract both sides by 12, we're going to have 2x is equal to negative 4. I'm going to divide both sides by 2. So x, well, not equal to a, greater than or equal to. So now when we divide both sides by 2, then x is going to be greater than or equal to negative 2. So based on that, we could just say anything that is greater than or equal to negative 2. So as the solution, let's just say, if we drew this on a number line, this is negative 2, negative 1, 0, 1, 2, 3. So negative 2 and everything greater than negative 2. Okay, so last example I want to go into. Okay, so I'm gonna go through this one a little bit faster, but on the left side, we can distribute. That should be 45 minus 5x. On the left side, we're also going to distribute. That should be 4x plus 72. All right, so what I'm going to do is I'm going to bring over this 45. We're going to left with negative 5x. Then we're going to cancel this out, and we have 72 minus 45, which is 27. Now we're going to subtract 4x on both sides. we're going to be left with negative 9x is less than or equal to 27. Okay. So this is where inequalities are different from regular equations. Okay. So what should be our last step right there to solve this? What is the last thing that we need to do to solve for x right there? Divide, right? So I always say almost always our last step would be to divide. So we're going to divide both sides by negative 9. So that cancels out and we're left with x, and 27 divided by negative 9 gives us negative 3. All right, but here's what's important. What happened to the 27 when I divided it by negative 9? So when I divide something by a negative, what happens to that? If it's a positive number and I divide it by a negative, what happens? Well, not that it turns positive. So if we divide a positive by a negative, it actually turns negative. Okay. So what that makes is that what happens is that that inequality looking like that no longer makes sense. Okay. Because then we just went from a positive to a negative, and so all of a sudden we went from it being greater than 27 to now being greater than negative 3. It really doesn't make sense. So what we need to do is flip the inequality sign towards the other way. Okay, so that's the big difference here. Whenever we divide or multiply in our last step, because we almost always divide, but sometimes we multiply. Whenever we divide by a negative number, we have to flip the sign. Now it becomes really important. We have to flip the sign. Because I'm sure in the star, they're going to give you both of the answers where it would look like this. And if you don't know that rule, you could pick this one instead of this one, which is the correct answer. Okay. So work on this a little more tomorrow.